Hi folks, Mr. Long here. I'm going to work through the type 4 tangent problem in calculus. This is by far the toughest question, and this is not a question that's worth a whole lot of marks on any assessment. This is really how you get the high level 4 marks. So if you're looking to get those marks above 90, for example, it's through a question like this. But again, you can get up to that, basically that 90% mark without even doing this type of question. Okay, so these are really tough ones. Anyway, I'll go over this. The big idea here is that we've got a tangent, and we know a point on the tangent, but that's not the point of tangency. Okay, that's not the point of tangency. So if we were to look at this, we want to look at a picture just to get the idea. So in this question, what's given is that there's a point, negative 1 comma 7, which sits on a tangent. Okay, and that tangent negative 1 comma 7 is not the point of tangency. So the other thing that's given in this type of question is the original function. Okay, so the original function. So what we want to do in order to, again, to draw that sketch so that we understand the problem is we figure out where the vertex of that parabola is. And that's nice and easy to do now that you know some calculus. We know that the slope of the tangent is 0 at the vertex. Okay, so I'm going to get the tangent slope function. So negative 3x squared has a tangent slope of negative 6x, right? Negative 3 multiplied by 2. And then reduce the exponent by 1. And then I've got this part here, the line, 18x plus 1. Well, what's the slope of that? 18. So plus 18. So at the vertex, we know that that's 0. And I solve that equation right there. And I know that the vertex of the parabola is 3. I also know that the parabola opens down. Okay, so let's take a look again at this picture. So I know that that's what my picture looks like. I've got a tangent, and it's it starts right here at negative 1 comma 7. So again, I'm just sort of guessing, and I know the y-intercept of the original function is 1, and I know it's opening down because it's a negative, and I know the vertex is at x equals 3, right? We did that. So the tangent is here. So I know it's probably something like that. I can't be 100% sure, but I know it's something like that. So that's my picture, and that there alone, just having that tells me that you understand the situation quite a bit. Okay, so let's go back and start to look at some of the algebra that's involved. Again, please remember that this is a really tough question. Okay, so the point of tangency, okay, the point of tangency is at a comma f at a. Any function notation remains tough, I know. So that's your x value and that's your y value, right? So your x value is at x equals a, your y value is f at a. We don't know what a or f at a is in this scenario, right? I only know the original function and I know a point on the tangent. So, but I'm always going to work with two things. I'm going to work with f at a and I'm going to work with f prime at a, or f at x and f prime of x. So let's start doing that. Okay, so maybe to begin, let's look at what is f at a. So I know that f at x is negative 3x squared plus 18x plus 1. So I'm going to sub in a. So I do that. I sub in a, and I get negative 3a squared plus 18a plus 1. So that's an equation of the original function when I replace x with a, the point of tangency. Then what I do is I go over and I do the exact same thing with the tangent slope function. So we've already got the tangent slope function. We figured out it was at negative 6x plus 18, and I replace x with a. So now I have that as my tangent slope function. So really, and remember in math, it's really about what can I do, and then start to piece things together, right? So I get f prime at a, I get f at a, and again, I don't know what a is, but at least I can substitute it in. I start having some equations that I might be able to work with. And I definitely know the tangent equation, right? There's our original tangent equation. right? That's the tangent equation. So if I look at this, I know, and I'm going to bring this down a bit. So I know this is my tangent equation. The y value of the tangent is f prime at a, the slope of the tangent, x minus a, and then I have f at a right there, the y value at the point of tangency. So that equation is true all the time. Well, do I know any of these things? Well, I know the ordered pair that's on the line, x and y, is negative 1 and 7. It's not the point of tangency. It's an x and y value on the tangent. So I'm looking at what can I substitute into this equation, right? What can I substitute in? And remembering that I can solve any equation as long as there's only one variable, okay, one unknown. So I know that yt is going to be 7, because that's a y value on the tangent. X is going to be negative 1. Notice I'm color coding here. So that x is going to become negative 1. F prime at a. Well, I do know f prime at a. I don't know a number for it, but I know it in terms of a. Right, so a is an unknown, so I can replace f prime at a with negative 6a plus 18. And then what about f at a? Well, I think I can probably replace f at a. There's f at a right there. I can replace it with this f at a, which is only in terms of a. So now I'm going to substitute each of those things in. I probably need to zoom that down a bit there. Okay, so the y value is 7. The x value is negative 1, that it's on the tangent. F prime at a is replaced with that f prime at a. And then f at a is replaced with that f at a. Notice, if I go all the way through that equation, there's a 7, there's an unknown called a, there's an unknown called a, unknown called a, unknown called a. So even though this is a fairly complex equation, there's only one unknown, a. So now it just requires some algebra from grade 10 and 11, expanding out binomials, right? So negative 6a times negative 1, negative 6a times negative a, 18 times negative 1, 18 times negative a. So we expand all that out, and plus we've got this at the end. And then there's just a whole bunch of algebra there to do. Okay, there's a whole bunch of algebra to do. So what sorts of things do we do? Well, I identify like terms this way. So 6a squared, negative 3a squared. Well, if I simplify that, I get 3a squared. Then I look for my a terms. So there's an a term there, there's an a term there, there's an a term there. So negative 18a, 18a. That cancels out. It adds to 0. So I'm left with 6a. And then I have to do my constants. Negative 18 plus 1 and this 7 over here. When I simplify all that out on the right side, I end up with negative 24. So it looks like I have a quadratic, so potentially two solutions. So when I'm solving an equation, I can just divide out a common factor and divide both sides by 3, because 3 is the common factor to all those. So I divide everything by 3. I end up with this equation right here, which is a nice and easily factorable equation, or you could use polysolve on your TI 36. A squared plus 2a minus 8 becomes a plus 4, a minus 2. And in this type of question, my preference is that you just figure out where the tangents are. So the locations of our tangents then are at a values of negative 4 and 2, which are the x values of the point of tangency. What I could do now is go in and back substitute and get the actual tangents, but that's quite a bit of work, so I think I'm okay with just knowing where the tangents are located. Okay, but if I want to get the slope of the tangent, or I want to get the y value of the point of tangency, I can do that as well. Okay, but I think I'm pretty happy as a teacher if you can get to this point. Again, I'd encourage you to go through these problems again. Again, this is a particularly tough one, but hopefully you'll be able to get through some of these. Okay, so again, pause, rewind, go over it, make some notes, etc.